In this video, I'm going to show you how to generate a rule from an input-output table. Off to the side of the table, I have what's called a function machine. This right here in the middle is my function machine, and it has some sort of mystery rule that I don't know at this time. And whatever number that I put into the function machine, in this case, I'm going to call it x. That rule is applied to that number, and it spits out another number that I'm going to call y as its output. So up here on my table, I'm going to call this the x and this the y. I'm using x and y because I may want to graph my data on a coordinate plane that has an x-axis and a y-axis. I'm going to start out by thinking of a rule, but not revealing it just yet. And instead, what I am going to reveal is inputs and outputs. And what I suggest you do is watch the numbers that I'm revealing and see if you can develop any educated guesses about what you think the rule might be. And as you develop guesses, keep applying it to each number that I reveal in the input-output table to make sure that your rule still works. And if it doesn't, revise your guess to fit the new data that you are receiving. So my first input is going to be a 3, and the output will be 12. So hopefully you're thinking of several possible rules right now, and maybe you've narrowed it down to x times 4 equals y. 3 times 4 does equal 12. Maybe you've thought of x plus 9 equals y. But right now there's actually an infinite number of possibilities for my rule. I could have all kinds of things like x plus 18 minus 9 equals y. 3 plus 18 is 21. 21 minus 9 does equal to 12. I could even have x times 1000 minus 2988 equals y. 3 times 1000 is 3000 minus 2988 does equal 12. So as you can see right now, there's just not enough information for us to have a definitive guess about what the rule is. So I will give you some more information. Let's say the input is now 10 and the output is 40. So now check whatever rule that you are thinking of and see if it still works. So if I go down to this one on the bottom, x times 1000 minus 2988, I've now have 10,000 minus 2,988 that's not 40. So this one right here is definitely out now. Same thing with the second to last one. 10 plus 18 is 28. Minus 9 is again not 40. It's out. And 10 plus 9 is 19. That doesn't equal 40. However, 10 times 4 does equal to 40. So I have a fairly good educated guess right now. This is what I think the rule might be, but I really need some more information to be certain. So let's give another number. Let's say that if the input is 12, the output is 48. 12 times 4 does equal 48. So again, this is confirming my guess of x times 4 equals y. And if I filled in the entire table, it would confirm that my rule is correct, which is multiply by 4. Here's another example of an input-output table. And I've already filled in the table in this example, but I've left a few blanks that you can then fill in once you know the rule. So really, the only information I have to start with is right here and right here. I'm going to have to be able to figure out my rule using those two input-output numbers. So it looks like my numbers are getting smaller. So that means it's most likely going to be division or subtraction. And in my first example at the top, 48 and 6, if that were subtraction, it would be subtracting 42. And down here, I'm clearly not subtracting 42. So it's most likely division. If it were division, 48 divided by 8 equals 6. And 16 divided by 8 does equal 2. So now I know that the rule is dividing by 8. And I can apply that rule to the other numbers the other input numbers that are in the table. 56 divided by 8 equals 7, and 72 divided by 8 equals 9. Now, my last blank that I have the output number, but I don't have the input number. So if I take the input and I divide it by 8, which is the rule, I should get 11. The inverse of division is multiplication, so if I go backwards, I'm going to multiply 11 times 8, which would give me 88. This next example is a little bit different also because I've already given the rule. And in this case, the rule has two operations. The rule is times 2 and then plus 1. So I've got some missing numbers in the input-output table, and I'm going to apply the rule and see if I can solve for those missing numbers. And the first thing that I'm going to do is I'm going to rewrite my rule. The rule is taking the input number, the x, multiplying it by 2, then adding 1. That should give me the output number, the y. Now this is the same thing as saying 2x plus 1 equals y, because x times 2 is the same thing as having 2 x's. So now I'm going to substitute my input numbers for the x and evaluate the variable expression for y. So that means I have 3 times 2 plus 1. 3 times 2 is 6, plus 1 equals 7. Then I have 5 times 2 plus 1. 5 times 2 is 10, plus 1 equals 11. I'm going to skip down to the 10. 10 times 2 plus 1, that is 20, plus 1 is 22. And the missing parts that I have left are now where I have the outputs, the y's. So when I substitute them back into my equation, I am going to plug them in for the y. So when y equals 13, I have x times 2 plus 1 equals 13. To solve for this, I need to take 1 away from both sides. That leaves me with x times 2 equals 12. And the inverse of multiplication is division. So I can do 12 divided by 2, which gives me x equals 6. The last one, again, I have x times 2 plus 1 equals 41, because the output is 41. Subtract 1 from both sides. That leaves me with x times 2 equals 40, and 40 divided by 2 equals 20. Let's look at one more example with a given rule with two operations. So in this input-output table, our rule is divide by 2 and then add 2. If I rewrite that rule, I'm taking my x, I'm dividing it by 2, and then I'm adding 2. I don't need parentheses, but I'm going to go ahead and put parentheses to remind me that I need to divide before I do addition according to the order of operations. So when I do all that, then I'll get my output. I can also write this as x over 2 plus 2 equals y. X over 2 is the same thing as x divided by 2. Now I'm ready to start substituting the inputs in to solve for the outputs. So I'm going to start with 4, and I'm going to go ahead and just rewrite my equation here. 4 divided by 2 is 2, plus 2 more equals 4, so y equals 4. 12 divided by 2 plus 2 more, that's 6 plus 2, so y equals 8. And the last one is 100. 100 divided by 2 plus 2 more, that's 50 plus 2, so y equals 52. Now I'm ready to substitute the y values, the outputs, to solve for the inputs. So on my first one, I have x divided by 2 plus 2 equals 10. The first thing I need to do is subtract 2 from both sides. That leaves me with x divided by 2 equals 8. So the inverse of division is multiplication. So if I do 8 times 2, x equals 16. And the last one, x divided by 2 plus 2 more equals 17. Subtract 2 from both sides. I have x divided by 2 equals 15. The inverse of division is multiplication, so 15 times 2 gives me x, and x equals 30. I'm going to end this video with a challenge. I've used a rule that I haven't revealed here to create this input-output table, and this input-output table has enough information in it for you to discover what that rule is. My challenge for you is to see if you can find out what that rule is, and then use the rule to find the missing input and the missing output.